Hello everyone, I am Dr. R.V. Parimala, Professor and Head, Department of Electronics and Communication Engineering, Maharaja Institute of Technology, Mysuru. Here, we will be discussing about the syllabus of Introduction to Electrical Engineering. This is the basic course which comes in the semester 1, and the course code for this is BES CK 104B. BES meaning Basic Engineering Science course. 104B is one representing the first semester course, and if it happens to study in the second semester, the code remains the same except for the numerical 1, it is going to become 2 there. So it will be BESCK 204B if you study the course in second semester. The course type, it's a theory course. You will be studying only the basics of electrical engineering. Teaching hours per week, it will be divided as lecture hour, tutorial, practical and the project component where S stands for project. Here it will be only the lecture hours of 3 hours per week, and the total credits reserved for this is 3. So in this video, I will be detailing about the course contents of Introduction to Electrical Engineering. Before proceeding for the detailed syllabus, let me give you the brief introduction of this course. So Introduction to Electrical Engineering mainly focuses on power generation and DC circuits, AC fundamentals and 3-phase circuits, DC machines, transformers and induction motor, domestic wiring, electricity bill, equipment and personal safety measures. That's a brief syllabus. Now let me take you to the detailed syllabus of Introduction to Electrical Engineering. So you will be having 5 modules. In module number 1, we are going to study the basics of electrical engineering, starting with the power generation. The power generation basically divides into 2 types, conventional and non-conventional. So hence it will be starting with conventional and non-conventional energy resources, general structure of electrical power system using single line diagram approach. So any power system structure will be comprising of generation, transmission, distribution. So generation, transmission, distribution, everything will be covered by means of a single line diagram instead of having all the components connected to the power system. So that's going to be studied under introduction part. Then coming to power generation, there are different types of power generations available, namely hybrid, nuclear, solar and wind power generation. So all those generations are going to be studied, how electrical energy will be generated by using hydel power plant, nuclear power plant, solar and wind power generation. So everything will be studied but with a block diagram approach. Instead of studying in detail the components connected to each part of it, you will be studying only with the block diagram how electrical energy is going to be generated by hydel and nuclear power plants. So now here, if you just look into that, hydel is a conventional method, the nuclear is also a conventional method. When you come to non-conventional, it is solar and wind power generation, it is not conventional. And again actually the power generation is classified into 2 types, which generally we do it, that we are not going to discuss in detail for the basic electrical engineering. Then coming to the next part of it, which is DC circuits. Under DC circuits, you will be studying about Ohm's law and its limitations, then Kirchhoff's current law, Kirchhoff's voltage law. Then you are also going to study about series, parallel and series parallel circuits, and with the small examples on each of that. That means Ohm's law, the statement of Ohm's law and the expressions included for Ohm's law, and also its limitations you are going to study. Again, coming to Kirchhoff's current law and voltage law, the statements you are going to study, and we also study how Kirchhoff's current law and Kirchhoff's voltage law will be applied to a particular single loop and two loop network. Then you are also going to study about the series combination of resistors, series parallel combination of resistors, series and parallel combination of resistors. That covers module 1. Then coming to module 2, you will be studying about AC fundamentals. So that is alternating current fundamentals. There you will be studying about how alternating current is going to be generated. After studying that, how a waveform look like, based on that you are going to study about the equation governing the AC quantity, and also you are going to study about the different constants that you have to understand there. So that is equation for AC voltage and current you are going to study, the waveform which is a sinusoidal waveform, and you also discuss, or you are also going to define something about time period, frequency, amplitude, phase difference, average value, RMS value, form factor and the peak factor. So, you are going to explain only the definition part of it, and also a part of it you are going to derive. Apart from defining the constants of AC quantities, you are also going to study something about the voltage and current relationship in case of a series RL circuit, RC circuit and RLC circuit. And after having studied about that, you will be studying something about the relation between active, reactive and apparent power. You are also going to derive the expressions for that, and you are also going to understand the concept of power factor, and based on this you will be solving few problems. Next, in the module 2 itself, along with the single phase AC circuits, you are studying 3-phase AC circuits also. So, this covers generation of 3-phase AC quantity, that is generation of 3-phase AC voltage, and advantages of 3-phase over single phase. Then you are also going to study something about the limitations of 3-phase, and the two important circuits that you are going to study in this is star and delta connection, the relationship between the line and phase quantities of star and delta components that you are going to study in this particular module. Next, module 3 discusses something about DC machines. When you say DC machines, it is classified into two types, DC motor and DC generator. So, first you are going to study about DC generator, and for the DC generator, it is a generator which is going to generate the voltage. So, you are going to study the principle of operation, like how the DC voltage is going to be generated, that is principle of operation. You are going to study also about the constructional details of DC generator, and then you are going to derive the expression for induced EMF, that is induced EMF expression. Then different types of generators like series, parallel generator, compound generators, like that you are going to study, that is self-excited generator and separately excited generator. The classification you are going to study basically in this. Then the relationship between the induced EMF, the terminal voltage, you are going to do it. So, there you are going to come across an important factor called flux and also the speed in revolution per minute, that you are going to study. The relation actually for the induced EMF and the voltage also you are going to study, and an expression for EMF which is in terms of the number of conductors, the speed in revolution per second, flux and number of poles and the parallel paths. So, that you are going to study in DC generator. Then coming to DC motor, you are going to study once again how a DC machine, the same machine can be run as a generator as well as a motor. The same machine can be run as a motor also. So, what is the principle involved for this, to run the given machine as a motor? Then the concepts like back EMF and its importance, torque equation you are going to study, the types of motors, characteristics of each of the motors, again types of motors if I say, series, shunt and the compound motors you are going to study, and their characteristics, that is speed versus flux characteristics, and then as the load varies, how the speed varies, as the load varies, how the torque varies. So speed torque characteristics you are going to study there, and also you are going to study the speed control of DC motors. So there are two types there, one is called armature control and the other one is the flux control. Both the things you are going to study there. Next, coming to module 4, again it is the continuation of machine itself. In the module 3 you will be studying DC machine, and in module 4 you are going to study AC machine. And in AC machine basically you are going to study about transformers and 3-phase induction motors. So when you say transformers, you are going to study the necessity of transformer, principle of operation, types and construction of single phase transformers, again EMF equation, the different types of losses that is going to occur in transformer, variation of losses with respect to the variation in the load current, then efficiency and simple numerical problems based on that. That we will be studying in transformer. And under 3-phase induction motor, once again we are going to study about the concept of rotating magnetic field, how the rotating magnetic field is going to be generated for a 3-phase induction motor, the principle of operation of that, what is the basic principle involved, then constructional features of 3-phase induction motor, the different types of 3-phase induction motors such as squirrel cage induction motor, slip ring induction motor or wound rotor induction motor, and the concept of slip and its importance you are going to study with very simple problems on 3-phase induction motor. Then coming to module 5, the most important aspect each and every human being need to know about it is domestic wiring. So domestic wiring, everybody have homes, houses, and every house is now fixed with all the electrical apparatus, appliances, and there is a meter board, energy meter, from where the KB people, they'll come read and take the reading, and then finally they are going to give you, this is what is the bill you have to pay. So for that, the different types of wiring that's happening in domestic wiring that you need to know, that is what is the requirement for a particular house to be wired and what type of wiring we have to do. Then different types of wiring that is available right now in the current trend. So like casing capping and concealed wiring. You also have to study something about 2-way and 3-way control of lamp, a single lamp, how it can be controlled by 2 or 3 different switches, which is already you are doing it, that you are going to study. Then coming to electricity bill, which is the most important aspect, everybody need to know about that. So what is the power rating of household appliances, including household appliances, if I say it is air conditioner, it can be air conditioner, personal computers, laptops, printers, etc. Maybe you are using washing machines, you are using mixer grinder, fridge, everything, whatever the appliances you have it, for everything, what is the power requirement? So power rating, that is most important. Based on that only you will be given or sanctioned a particular load consumption, and based on how much you have consumed per month, you will be charged. So whatever the charge you are going to be given is the tariff, that we are going to call it as tariff, and there are different ways of calculating the electricity bill. So that you are going to study in this particular module, and you are also understanding the concept of what each unit of energy means. So definition of unit used for consumption of electrical energy. You are also going to study about 2-part electricity tariff, the calculation of electricity bill for domestic consumers. So it's only restricted to domestic consumers. The tariff calculation for domestic, commercial and industrial, it is different. So for all the customers, domestic customer, industrial customer and commercial customer, the tariff will be different, and here it is restricted only to the domestic wiring. So then you also have to know, when you are dealing with electricity, you have to be very careful. So both the human being as well as the equipment connected to electricity should be saved, should be protected. So that we are going to study under equipment safety measures and personal safety measures. So what are the things you have to consider for equipment safety measures, such as working principle of fuse? You need to know that is one of the best protective devices we have at home, and also MCBs are there which are going to trip if the load exceeds or if short circuit happens. So that you are going to study in this module, that is for the equipment safety measures. You also study about the merits and demerits of fuse as well as miniature circuit breaker or MCB. Then under personal safety measures, if a person is exposed to electric shock, how he has to be protected. That is the most important thing, and generally everybody tries to know what exactly they have to do when a person is exposed to electric shock. Then earthing of electrical equipments and its different types, and how earthing protects both the human being as well as the equipment, that you are going to study there. The safety precautions to avoid shocks, how exactly we can avoid the shocks. So these are the things you are going to study in electrical engineering or introduction to electrical engineering. So starting from the first module, if you just observe, the first it will be started with how the electricity is going to be generated. Then next, the different methods of calculating what is the current, what is the power consumed, what is the voltage, etc., etc. Then it is actually dealing with both DC and AC circuits. So AC, if you say the fundamentals, series and three-phase circuit you are going to study. Then after that you are going to study the different types of machines that you are going to come across in your daily life, that is DC and AC machines. The most important machine that you are going to come across is transformer. You are going to study about that, and also induction motor. Then finally ending up with the domestic wiring and personal and the equipment safety measures. So that covers the entire syllabus of introduction to electrical engineering. Then the course outcomes. What are the course outcomes? So course outcomes means after studying this particular course, what is that a student is able to do? What are the things the students are able to do? So whether they understood that, whether they are going to carry out that, etc., etc. So for that you have so many course outcomes. Here we have marked CO1, that is course outcome 1, course outcome 2, course outcome 3, course outcome 4 and course outcome 5. If you just look at course outcome 1, it says understand the concept of various energy sources and electric circuits. So after studying the module 1, the student will be able to understand the different types of energy sources that is available for the generation of voltage, and after that he will be able to study how an electric circuit can be solved to find out the current, power, etc. So that is course outcome 1. Coming to course outcome 2, apply the basic electrical laws to solve the circuits, such as Ohm's law, Kirchhoff's current law and Kirchhoff's voltage law. So application of these laws to electric circuits to find out the power, current and also the voltage. Then coming to course outcome 3, it says discusses the construction and operation of various electrical machines. So it may be DC machines or AC machines. The student will be able to understand this particular concept, the constructional details and the principle of operation of all the different types of machines. Then identify suitable electrical machine for practical implementation. That's most important. What is the machine which you have to use for a particular application, such as maybe for the fan or maybe for your washing machine, etc. Which particular machine we have to use, maybe for the traction, which particular machine, that is for your BMRCL, which one they are using it. So for all those things we are going to understand after studying the machines part. Then finally we have course outcome 5, wherein explain the concepts of electrical power transmission and distribution, electricity billing, circuit protective devices and personal safety measures. All those things the student will be able to understand, able to know, able to implement once he study this particular course. Then That is regarding the syllabus and the course outcome. What are the suggested learning resources? So learning resources are plenty now, but here we have identified with the books and the web links. The textbooks that you are going to use to study this course: Basic Electrical Engineering by D.C. Kulshrestha, and generally the order of the books given here is the first one represent the title of the book, followed by the author name, then the publisher and the year of publication. So Basic Electrical Engineering is the title of the book, D.C. Kulshrestha is the author name, Tata McGraw-Hill are the publishers, and the publication happened in the first edition in 2019. Similarly, a textbook of electrical technology by B.L. Taraja. B.L. Taraja is the author name, and S. Chand and Company is the publisher, and it was reprinted in the year 2014. And there are reference books also here: Basic Electrical Engineering by D.P. Kothari and I.J. Nagrath. Once again, the publishers are Tata McGraw-Hill, and it is the 4th edition book which was printed in 2019. Then Principles of Electrical Engineering and Electronics by V.K. Mehta, Rohit Mehta, yes, and the publishers are S. Chand and Company. Then it is the 2nd edition book which you have to refer. The last one is Fundamentals of Electrical Engineering by Rajendra Prasad. PHI is the publisher. It is 3rd edition which was printed in 2014. Web link, if you have to look for, it is NPTEL course www.nptel.ac.in. There if you refer, you will get the materials or the contents, whatever I have told, you will get it there as a material. Then importance of the course, why you have to study this? So that is the major question, everybody gets it. So the most important answer that I can give here is electricity is being used by each and everybody everywhere, entire world is using the electricity. So you will understand the importance of electricity only if it is absent. Only during power cuts you understand the importance of electricity. It's like the air that we are going to breathe, and hence, so this is very, very important for each one of us to know about the introductory course on electrical engineering. So the fundamental knowledge of electrical system is essential for all. Every individual should be aware of electricity bill calculation. That's very important now, how it is happening. Everybody, whether he is a technical person or non-technical, he should know how they are going to calculate, what is that they are going to charge. Being the customer, it is our right to know about that. That calculation part you are going to study here. So that is why this is important for you. And most importantly, everybody should know the personal safety measure and the equipment safety measure. Both need to be protected, and that every single individual need to know about that. That we are going to study, and hence this is very important for a budding engineer. And then we have also come to know about the importance of that. Then how the assessment is going to happen for this particular course. Since it is a theory course, you have 2 types of assessment. One is continuous internal evaluation. The other one is semester end examination. Continuous internal evaluation basically will be conducted during the semester itself. It is 3 such continuous internal evaluation are going to happen during the semester. Maybe after 5 weeks of the commencement of the semester, 1 continuous internal evaluation will be there, which we are going to call it as internal assessment test. Similarly, after 10 weeks, then after 14 weeks. So like that, you are going to have 3 internal assessment, and 3 internal assessment will be done for 20 marks each. So adding all the 3, it is going to be 60 marks. Then apart from that, you also have got one assignment component. It can be assignment or maybe a quiz kind of thing, or maybe any other activity which will be asked by the faculty members to conduct. So that is for 40 marks. If any course teacher feels like conducting the project on that, so project will also be there, project report will also be there, like that. So that will be done for 40 marks. So total marks of CIE will be 60 from internal assessment and 40 from the assignment, totaling together 100 marks, and that will be scaled down to 50 later. And then next we have semester end examination. Semester end examination will be conducted for 100 marks. So there are 10 questions and 2 questions from each module. The student should answer 5 questions, selecting 1 question from each module. Module 1, module 2, module 3, like that. So from each module should select 1 question from each module. So each question will be for 20 marks. If a student answers 5 questions, he will be answering for 100 marks. That will be again scaled down to 50. So continuous internal evaluation of 50 marks, semester end examination marks of 50 marks. Together if they sum it up, it is 100 marks. That is, for 100 marks, a student should score 40. I explain it once again. CIE, continuous internal evaluation, 40% of this continuous internal evaluation marks he has to score. That is, CIE marks should be 40% of the total marks of 50. That means 20. A student should score 20 out of 50. If he doesn't score 20 out of 50, he is not eligible to write the final examination. This we are going to call it as NSSR. NSSR, that means not satisfied sessional requirement. If he doesn't satisfy the sessional requirement, he is not allowed to write the final examination. So 20% of internal assessment marks out of 50, he should score 20. Then from the semester end examination, he has to score 35%. That means 18 out of 50 in the final examination, that is semester end examination. But together CIE and SAE, it should be 40. So only even if it is 20 here in internal assessment and semester end examination 18, adding together it is going to become 38. In that case, the student is failed. He has to clear the paper, he has to score 40 out of 100, totaling CIE and SAE. So that is the rule.